Lesson 68, complex fractions. We're going to combine a couple of concepts that we've used before for individual problems. So let's take a look at this weird fraction we've got over here on the left, which might look kind of intimidating at first, but we're going to take it one step at a time. So we've got x over y plus 1 over y over x over y minus 1 over y. And we're going to simplify this fraction. Now, there are a couple of things going on here. First of all, we've got fractions being added both on the top of this fraction and on the bottom of this fraction. And then also, we've got the issue where we have a fraction on top of a fraction and a fraction on the bottom of the fraction. That's okay. We're going to take it one step at a time. And first, we're going to add these fractions. Because remember, in terms of our order of operations, the top of a fraction and the bottom of a fraction, those count as things inside parentheses. So we have to do those first before we do anything that goes across that line. So first on top, x over y plus 1 over y, pretty straightforward. They already had the same denominator, so we can just add the numerators together, and we get x plus 1 over y. Similarly, the bottom of the fraction, x over y minus 1 over y, they already had the same denominator, so we can just add the numerator straight across, x minus 1 over y. Okay, at this point, we've got a fraction on top and a fraction on bottom. And the easiest way, I think, to do this is by remembering, you can either think of it as the keep, change, flip rule from dividing fractions that you probably learned earlier, or if you remember with our negative exponents, how we flip things when we move them between the top and the bottom of the fraction. So in terms of this, one of the things we can do is, instead of thinking of this as division, we can think of it as multiplication. And if we multiply, then we'll flip this guy over on the bottom. So we get x plus 1 over y, right? That's the keep. The change is, instead of this division here, we're going to use multiplication. And the flip, we'll flip this fraction over, so we get y over x minus 1. Now at this point, before we multiply across, we see if we can cross anything out, eliminate anything. And we see we've got the y on top here and the y on bottom here. Those will eliminate. And our answer is going to be x plus 1 over x minus 1. That'll be our final answer there. Be careful. Do not try to simplify these x's away. Those x's do not cancel each other out because they're connected by addition on the top and the bottom of this fraction. You can't undo addition by division, which is that kind of canceling out that you're thinking of doing. Let's take a look at a slightly more complicated one. Over here, a over b plus 1 on top over x over b plus 4 on bottom. So same first step. We're going to add these fractions on the top, add these fractions on the bottom. Have to do that first to follow our order of operations. So to add a over b and 1, we need to make them have the same denominator. That denominator, of course, is going to become b. So a over b plus, when we take 1 and get it to have a denominator b, that's by multiplying the top and the bottom each by b. So that's b over b. And then on the bottom, similarly, we're going to get them both to have a denominator of b. So x over b plus 4b over b. Now we can add on the top and add on the bottom. On the top, we get a plus b over b. And on the bottom, we get x plus 4b over b. Same thing again. Now that we've added on the top and the bottom, we're going to keep, change, flip. So we'll keep our a plus b over b. Maybe this is a little better. We'll change division to multiplication. And we'll flip this guy, so we end up with b over x plus 4b. Again, when we look at this, we see we've got this b here, that can cancel each other out because this is multiplication, so we can cancel out that way. And then we're going to end up with a plus b on top and x plus 4b on the bottom. And again, we can't simplify. We can't get rid of those b's there because this is addition happening here, not multiplication. Okay, last example. This is a particularly Saxon-y one, a little bit more complicated than necessary. A to the negative 1x plus b to the negative 1y over x to the negative 1. A couple of different ways that we could approach this, but to follow this method, Now, wait a minute. I thought we were dealing with fractions on top and bottom, and I don't see any here. Remember that our negative exponents are another way of writing fractions. So a to the negative 1x, we can rewrite that as x on top and a to the 1, or just a, on the bottom. You can rewrite that as x over a. Similarly, b to the negative 1y, we can rewrite that as y over b, because a to the negative 1 is the same as a on the bottom of a fraction, and b to the negative 1 is the same as b on the bottom of a fraction. Now, once we do that, we change it. Now we see we are, in fact, adding fractions on the top. On the bottom, again, the x to the negative 1, we could decide to move it up to the top, but let's stick with this method here, and let's rewrite it as a fraction, 1 over x. Okay, now we're going to follow all the same steps as before. It's just going to be a little bit more complicated. So we're going to add x over a and y over b. The common denominator is going to be ab, so we need to change x over a to have ab on the bottom. Multiply the top and the bottom both by b, so we get xb over ab over ab, not a plus b. And then y over b, we need to get that denominator to ab, so we multiply both by a, ya over ab. Right, now we're going to be able to multiply those. Remember, we haven't done anything to the rest of our fraction yet, so let's just keep it there. All right. Now we can add these together on the top since they have the same denominator. So we've got xb plus ya over ab over 1 over x. Okay. Now we've done our simplification on the top. We've done our simplification on the bottom. Now we can keep change flip. So xb plus ya over ab. That's the keep. Then the change to multiplication. And 1 over x will become x over 1. All right. Now we multiply these out. We'll get x times xb plus ya. You could distribute that if you wanted to, but you don't have to, over AB. And that's it. There's nothing else we can simplify here because we can't divide out AB from the top.